Black holes are one of the most mysterious and fascinating objects in the universe. They are regions of space where the gravitational pull is so strong that nothing, not even light, can escape. This makes them invisible to the naked eye. But their effects on the surrounding space can be seen and studied. Black holes form from the remnants of massive stars that have collapsed under the force of their own gravity. As the star collapses, its mass is compressed into a small space, creating a singularity, a point of infinite density and zero volume at the center of the black hole. The boundary around the black hole, beyond which nothing can escape, is called the event horizon. Black holes come in different sizes, ranging from a few times the mass of the Sun to billions of times the mass of the Sun. The supermassive black holes are found at the centers of most galaxies, including our Milky Way galaxy. The study of black holes has been revolutionized by advancements in technology, such as X-ray telescopes, gravitational wave detectors, and computer simulations. Through these tools, scientists have been able to observe and study the effects of black holes on their surroundings, including their interactions with stars, gas clouds, and other celestial bodies. One of the most exciting recent discoveries in black hole research is the detection of gravitational waves, ripples in space-time caused by the collision of two black holes. This discovery confirmed a prediction made by Albert Einstein's theory of general relativity, which describes the fundamental laws of gravity. Another significant discovery in black hole research is the role black holes play in galaxy formation and evolution. Supermassive black holes are thought to be at the centers of most galaxies, and their gravitational pull can influence the orbits of nearby stars and gas clouds. This can lead to the formation of stars and even the shaping of the galaxy itself. The study of black holes has also led to new insights into the nature of space and time. The existence of black holes has challenged our understanding of the laws of physics, and scientists are still working to develop a theory that can unify the laws of gravity with those of quantum mechanics. Black holes can be detected indirectly by observing their effects on nearby objects. For example, if a black hole is in a binary system with a star, it can pull gas from the star, which heats up and emits X-rays that can be detected by telescopes. Black holes are not actually holes in the traditional sense, but rather extremely dense objects with immense gravitational pull. In fact, the gravitational pull near a black hole is so strong that it can distort the paths of nearby objects and even slow down time itself. There are different types of black holes, including stellar black holes that form from the collapse of individual stars, and supermassive black holes that are found at the centers of galaxies. It is still unclear how supermassive black holes formed and how they became so large. There is a theoretical limit to the size of black holes, known as the maximum mass limit. This limit is thought to be around 50 billion times the mass of the Sun. And black holes larger than this are believed to break down due to a process known as Hawking radiation. Black holes can also be used as a tool to study the early universe. By observing the light emitted by quasars, which are thought to be powered by supermassive black holes, astronomers can learn about the conditions in the early universe and how galaxies formed. Some scientists have proposed the idea of using black holes as a means of interstellar travel. By harnessing the energy released by matter falling into a black hole, it may be possible to propel a spacecraft to relativistic speeds. However, this idea is still largely speculative and would require major technological advancements to become a reality. The event horizon is the point of no return around a black hole. Once an object crosses the event horizon, it is impossible for it to escape. The black hole's gravitational pull. The size of the event horizon depends on the mass of the black hole. The more massive the black hole, the larger the event horizon. Black holes are not actually black. They can emit radiation, known as Hawking radiation, due to quantum effects near the event horizon. However, this radiation is extremely weak and difficult to detect. Black holes can also spin, and the speed of their spin affects the shape of the event horizon. A rapidly spinning black hole has a more oblate, or flattened, event horizon, while a non-spinning black hole has a perfectly spherical event horizon. Black holes can also merge together, forming a single, more massive black hole. This can occur when two black holes are in a binary system and slowly spiral toward each other, due to the emission of gravitational waves. The first detection of gravitational waves, in 2015, was caused by the collision of two black holes. Some scientists believe that black holes could be the source of dark matter, the mysterious substance that is thought to make up much of the universe's mass. However, this idea is still speculative, and more research is needed to confirm it. The study of black holes has led to the development of new areas of physics, such as string theory and quantum gravity. These fields seek to reconcile the laws of physics as we know them with the extreme conditions found near black holes. In conclusion, black holes remain one of the most fascinating and mysterious objects in the universe. Their study has revolutionized our understanding of the laws of physics, and has led to new insights into the nature of space and time. As technology continues to advance, we can expect to learn even more about these enigmatic objects and the role they play in the cosmos.